Basicity of acid. We studied acids can donate proton. Acids can produce hydrogen atom as H plus ion. The number of H plus ion that can be produced from an acid is called its basicity. That is the number of ionizable protons present in an acid is called its basicity. For example, if you take hydrochloric acid, HCl, HCl can produce 1 H plus ion, right? That means basicity of hydrochloric acid is 1. Similarly, if you take HNO3 or HBr, HF, HI, all these can produce 1 H plus ion and hence their basicity equal to 1. And these acids are called monobasic acids. Such acids are called monobasic acids. These are examples of monobasic acid. Now if you take sulfuric acid, H2SO4 or carbonic acid, H2CO3, these two can give 2 H plus ion. They contain 2 hydrogen atoms. Both the hydrogen atoms are ionizable. Sulfuric acid can donate 2 H plus ion. Hence its basicity is equal to 2. And it is a dibasic acid. Sulfuric acid, carbonic acid are dibasic acids. Phosphoric acid, H3PO4. It contains 3 hydrogen atoms. All the 3 hydrogen atoms can be removed as proton, H plus ion. Means 3 ionizable hydrogens are present. Hence its basicity equal to 3. Tribasic acid. Or generally, if the basicity is more than 1, if basicity 2 or more, they are called polybasic acid. So these are examples of polybasic acid. Basicity 2 or more than 1, polybasic acids. Consider an example. Consider a polybasic acid H2SO4. It contains 2 hydrogen atoms. It can produce 2 H plus ion. Sulfuric acid ionizes to give an H plus ion plus HSO4 minus. After the removal of 1 H plus, it would become HSO4 minus. The equilibrium constant for this reaction can be written as Ka. This is denoted as Ka1, that is first acid dissociation constant or first ionization constant of the acid. Ka1, that is for the ionization of H2SO4 to give HSO4 minus and H plus, can be written as concentration of H plus into concentration of HSO4 minus divided by concentration of H2SO4. And this HSO4 minus produced here is still acidic because it contains 1 more hydrogen atom that is ionizable. So HSO4 can again ionize to give 1 more H plus ion plus SO4 2 minus. The equilibrium constant of this reaction, that is second ionization of bisulfate ion, can be written as Ka2. Second ionization constant of the acid. Ka2 will be equal to concentration of H plus into concentration of SO4 2 minus divided by concentration of HSO4 minus. When we compare the magnitude of Ka1 and Ka2, we see that ionization constant, acid ionization constant or acid dissociation constant of higher order acid dissociation constant, that is Ka2. Ka2 is always found to be smaller than Ka1. Second acid dissociation constant of sulfuric acid is smaller. First ionization constant of sulfuric acid is higher. This is due to the ionization of H plus ion or the formation of H plus ion from a neutral molecule is more easier. Ionization is more in the case of first ionization because the removal of a proton from a neutral compound is more easy compared to the removal of a proton from a negative ion due to electrostatic forces. So the first ionization process is easy. More degree of ionization will be in the case of first ionization of sulfuric acid. Hence, this value Ka1 will be first ionization constant of sulfuric acid will be always greater than second ionization constant. If you take tribasic acid, there will be 3 ionization constant Ka1, Ka2, Ka3. In that case also Ka3 will be smaller than Ka2, which is smaller than Ka1. Ka1 will be first acid ionization constant will be always higher than the second or third dissociation constants. Clear? Now let us discuss about factors influencing acid strength. Strength of an acid. Acid strength depends on 2 factors. Strength of an acid depends on, let us consider an acid of general formula for the acid HA. HA is an acid. The strength of this acid depends upon strength of the bond between H and A. Bond strength. HA bond strength. Acid strength depends on HA bond strength. And the second factor, HA bond polarity. Acid strength depends on HA bond strength and HA bond polarity. If the bond is very strong, first let us discuss the influence of bond strength on strength of the acid. If the HA bond is strong, the bond difficult to break. So removal of hydrogen as H plus will be difficult, right? The bond is difficult to break, hence removal of H plus is difficult. If removal of H plus is difficult, acid strength will be less. The acid will be weak. Difficult to produce hydrogen as proton. Weak acid. If HA bond is strong, removal of H plus is difficult because the bond is very difficult to break. Weak acid. Acid strength will be less. If HA bond is weak, if this is a weak bond, breaks readily. The bond breaks easily and can produce H plus ion easily. Removal of H plus ion is easy now. That means acid strength higher or acid strength increases. Means strong acid. So how acid strength and bond strength related? Acid strength vary inverse when acid strength increases. When bond strength increases, acid strength decreases. That means acid strength vary inversely with the bond strength. When bond strength increases, acid strength decreases. If bond strength decreases, acid strength increases. When we consider acids formed by elements of a group, for example, HF, HCl, HBr, HI. These are the acids produced from group 17. If you compare the bond strength of hydrogen and halogen, down the group we know the size of the halogen increases. Down the group, size of halogen increases. Down the group, the size of the halogen increases from height